Hi everyone! Welcome to part 2 of quadrantal angles. Here's today's FLT. Given a quadrantal angle in radians, I will be able to determine the trig ratio. So last time we looked at quadrantal angles written in degrees. Today we'll be looking at those same angles but written in radians. In part 1, we looked at quadrantal angles written as degrees, and we noticed that the quadrantal angles are in increments of 90 degrees. So we start at 0 degrees, 90 degrees, half a circle is 180 degrees, 270 degrees, and lastly, the full circle, 360 degrees. And just as a quick review, quadrantal angles are the angles where the terminal sides lie directly on the x-axis or the y-axis. So we looked at quadrantal angles written in degrees, but today we're going to take a look at quadrantal angles in radians. So first, let's use this conversion factor, 1 pi radian equals 180 degrees, to convert these quadrantal angles into radians. We know that 180 degrees is the same thing as 1 pi radian. So right here, 180 degrees and 1 pi radian both describe half a circle. Radians and degrees are just different ways of describing an angle. Now, what if we do a full circle? We're going a full 360 degrees, and so we're basically doubling half a circle. 2 half circles would equal a full circle. So how would we write 360 degrees in radians? 2 pi. And right here, I'm not writing the unit radians because whenever you see a pi, you just automatically think, oh, I'm using the radian unit. So 360 degrees and 2 pi radians are the same angle, just written differently. Now, what about 0 degrees? If we have a 0 degree angle, that would convert to 0 pi radians. But technically, we don't really have to write that pi, we just have 0. So 0 degrees equals 0 radians. What about this angle right here? Notice how it's half of a half circle. I know that sounds confusing, but it's going halfway of the half circle. And so what is half of 1 pi radians? We can write this as pi over 2. So 90 degrees converts to pi over 2 radians. And lastly, what if we go half a circle plus an extra quarter? So what if we go a full pi radians and then an additional pi over 2 radians? This would simplify to 3 pi over 2 radians. And if you have questions of how this converted, please let me know. When in doubt, you can always use the conversion factor and convert from 270 degrees into radians. But basically, 270 degrees equals 3 pi over 2 radians. So today we're going to still be looking at the same quadrantal angles, except for they're going to be written in radian form instead of degrees. So for example, if you see 1 pi, think, oh, that's the same as 180 degrees. And if you see 3 pi over 2 radians, think, oh, that's the same as 270 degrees. And since these are pretty common angles, I would actually recommend to memorize these angles both in degree form and in radian form, so that when you hear a certain angle in radians, you can automatically convert it in your head to degrees. So we have our quadrantal angles written in degrees here, going from 0 degrees all the way to 360 degrees. And let's convert these into radians. So this is just summarizing what we just worked on with the unit circle. Here are the same quadrantal angles written in radian form. So for example, 90 degrees and pi over 2 radians are the same angle, as well as 360 degrees and 2 pi radians. And remember that 0 degrees and 360 degrees are coterminal. They land at the same spot. And so 0 radians and 2 pi radians are also coterminal. So here's our chart of trig ratios of quadrantal angles that we worked on in part 1. I know there's a lot of trig ratios here, but as I mentioned in the earlier video, the main ones to remember are the sine values and the cosine values. So here the angles are written in degrees. But even if the quadrantal angles are written in radian form, like this, all the trig ratio values remain the same because, for example, 0 radians is the same thing as 0 degrees, just written with different units. And pi radians is the same thing as 180 degrees. So the trig ratio values remain the same whether we're looking at it as degrees or as radians. So with that in mind, let's take a look at some examples. For our first example, we are going to find the value of sine of pi over 2. So notice how sine of pi over 2, the unit is radians. We're going to rewrite this in degree format. So we know that pi over 2 is the same thing as 90 degrees. So we convert from radians to degrees. And we know from part 1 that sine of 90 degrees is 1. So that means sine of pi over 2 also equals 1. So we converted from pi over 2 radians to 90 degrees, and then we found the value for sine of 90 degrees, which equals 1. And an important thing to remember is that pi over 2 and 90 degrees represent the same angle. So although written differently, we're looking at the same angle. For example 2, we're going to find the value of cosine of 3 pi over 2. So what we're going to do first is rewrite this in degree format. So we know that 3 pi over 2 converts to 270 degrees. So again, we're quickly converting from radians to degrees. And we know that cosine of 270 degrees is 0. So that means cosine of 3 pi over 2, the same angle, is also equal to 0. Next, we're going to find the value of tangent of pi. So 1 pi is the same thing as 180 degrees. So we're going to be finding the value of tangent of 180 degrees, converting from radians to degrees. We know that this is equal to sine of 180 degrees over cosine of 180 degrees. Sine of 180 degrees equals 0, and cosine of 180 degrees equals negative 1. 0 divided by negative 1 equals 0, so we've found that the value of tangent of pi radians, in other words, tangent of 180 degrees, is 0. And remember, if you have any questions, please let me know. So for example 4, we're going to find the value of cosecant of 2 pi. In other words, we're going to be finding cosecant of 360 degrees, a full circle. Converting from radians to degrees. And we know that the cosecant function is the reciprocal of the sine function. So 1 over sine of 360 degrees. Sine of 360 degrees is 0, so we have 1 over 0, which results in an undefined answer. So cosecant of 2 pi radians is undefined. Go ahead and try this example on your own, and then press play when you're ready. So we're going to find the value of secant of 2 pi. That's the same thing as finding the secant value of 360 degrees. Remember to convert from radians into degrees. And secant is the reciprocal function of cosine. So we have 1 over cosine of 360 degrees. Cosine of 360 degrees is 1. So 1 over 1 equals 1. Notice how in our earlier example, cosecant of 2 pi was undefined, but secant of 2 pi results in 1. Here's our last example for today. We're going to find the value of cotangent of 0 radians, which is the same thing as cotangent of 0 degrees. From part 1 of the video lesson, we know that cotangent of 0 degrees would equal, make sure you have the correct order, cosine of 0 degrees over sine of 0 degrees. Cosine of 0 degrees is 1, sine of 0 degrees is 0, so we get an undefined answer. And I went over it in detail in the earlier video, but we know that cotangent of 0 degrees is equal to cosine of 0 degrees over sine of 0 degrees because cotangent is the reciprocal function of tangent. So just as a quick review, a quadrantal angle is an angle in which the terminal side lies on the x-axis or the y-axis. So here are the quadrantal angles written in both degrees and in radians. So for example, 90 degrees is a quadrantal angle, and written in radian format, it would be pi over 2. If you ever forget the quadrantal angles written in radian form, don't worry, just remember the conversion factor 1 pi radians equals 180 degrees, and this will help you convert between radians and degrees. Great work today, and please remember to submit your notes on Canvas. Thank you.